get started here soon. Just waiting on a couple others. Is it really just us three? Man, didn't this class used to have like 7 people? Oh well. Oh well, not much we can really do, I guess. All right, let's go ahead and take a look at let's keep going through the AMC, not AMC. Let's keep on going through the 2015 national level Mathcount sprint round. So yeah. Any so did any of you guys get to do any of the problems in the Mathcounts 2015 sprint round for national? Yeah, sure. Isabella, which ones did you get to do?
I didn't get any of them because they're really hard this week.
Yeah, it's the national test, so they're gonna be hard, yeah. But even then, like not a single one. It's pretty unfortunate then, I guess. Yeah, they're decently hard. Gracie, how about you?
No.
Okay, yeah, that's fine. No worries. Just wondering, because if you guys do have some that you guys were able to get, then we'd be able to talk about those that way. But if not, then again, it's not a big deal. Just wanted to get an idea if you guys got any of the questions or not. Okay, so since you guys didn't get any of the questions, then I'll just go ahead and kind of like talk through them all one by one instead of asking you guys if you guys did them. But I might ask you guys to kind of like, help me out with the calculations or anything like that. Yeah. Okay. So last time we talked about the first 6 problems. We talked about how the triangle inequality theorem meant that you had to have that, that biggest side, that 41, that had to be your biggest side. But that actually had to be, the one that was repeated, not the 18, because if you had 18, 18, 41, then that wouldn't work out. That was something that we learned there. But for problem number 7 here, this one's a little bit different. So problem number 7 says, for the first 30 miles of Raphael's trip, he traveled at an average of 45 miles per hour. For the remaining 20 miles of the trip, he traveled at an average speed of 30 miles per hour. What was his average speed for the entire trip? Express your answer as a decimal to the nearest 10. Okay, so let's take a look here. All right, Gracie, do you know the formula for speed? Like what does average speed really mean? Like what is that represented by?
We add them all up and then divide them.
So if you were traveling, say for example, an average speed of 10 miles per hour for a little bit, and then an average speed of 20 miles per hour for another little bit, I can average those two together and say you were going 15 miles per hour the entire time in total.
No, it depends on how long you were going for.
Yeah, so if you were going, 10 miles an hour for for 1 hour and 20 miles an hour for another hour, yes, for these cases, you can actually just go ahead and do a straight average of the two. But if you were going 10 miles an hour for 3 hours and 20 miles an hour for 1 hour, then you can no longer do a straight average. It doesn't work out that way. So what's going on here is we don't know how long they've been going on for each speed, and it doesn't work out that way. Now, overall, do you know the definition of speed? Like, what is speed?
How fast you're going?
It's how fast you're going. Well, yeah, but that's a very basic definition. So when we say miles per hour, right, that's the unit for the speed, right? In these cases, we're looking at miles per hour. What does miles per hour mean?
The amount of miles you travel in an hour.
Right. Or really the amount of miles divided by the amount of hours, right? Because I definitely brought this up in our algebra class. Isabella, you were there, right?
Yep.
When I said that miles per hour, what does the per represent? What does per mean, Isabella?
It's like each.
Each, it means division, right? So what we're seeing here is that miles per hour means miles divided by hours. So that gives us a really big hint that what we want is we want to find out, first off, how many miles do we go in total? And then second off, how many hours did we take in total as well? And if we can just take our average speed, that's going to be our miles divided by hours. Or distance divided by time. So this is a very famous formula that, this is something that we've talked about in our summer course. And Gracie, I think you were there, where we talked about how distance is equal to rate times time, right? Do you remember this, Gracie?
Yeah.
And if you divide both sides by time, that actually tells you that distance over time is equal to your rate. And that rate is your average speed. That is what you are looking at here. So this idea here, distance divided by time is equal to our rate. That's what we're looking for. So in order to solve this first question, we need to figure out first, how long did we drive? So Gracie, how long did Raphael drive?
50 miles.
That part's easy, right? We're told that his first 30 miles and his remaining 20 miles. So we're told that he had a total of 50 miles in his trip. That's pretty easy. Second part, how can we figure out how long he took to drive? How many hours did he take to drive? Gracie, how can we figure that out?
We multiply 45 times 30.
Ooh, I don't know about that one. Think about it this way, right? If you do 30 times 45, think about it this way. Think about it as 30 miles times 45 miles over hours. This should get you a unit in terms of miles squared per hour. That looks horrible, right, Gracie?
That looks terrifying.
Like this unit is just terrifying. And yeah, that's the point, because this unit is useless for us. It doesn't actually tell us anything. What we actually want is we want some sort of time, right? So we want hours at the end. Would you agree?
Yeah.
So what that means is we want to divide by miles, because if we divide by miles, that will get rid of miles. And we want to multiply by hours. So what we should actually do is we should multiply by 1 hour per 45 miles. So what we're really doing is we are dividing by this 45. Does that make sense?
Yeah.
And if you go back to that distance equals rate times time idea, what you get is distance over rate equals time. Distance divided by rate equals time, which is exactly what we're doing here. Does that make sense?
Yeah.
So how many hours does he drive in the first 30 miles? He drives for 30 over 45, which becomes 2 over 3 hours. Does that sound good to you?
Yeah.
Okay, and how long does he drive in the second half of his trip?
He drives 20 miles.
Well, he drives 20 miles, yes, but how long does he take to drive that long?
30 miles per hour.
well, I'm looking for a time, right? I'm looking for a measure of time. We do it the same way, right? We take our distance, divide by our rate to get our time, right? Distance equals rate times time. So if we divide both sides by our rate, we get the time equals distance divided by rate. Does that make sense?
Yeah.
So this formula is the key to solving this question. As long as you're familiar with this formula, as long as you know what you can do with it, as long as you can, divide both sides by rate, divide both sides by time, things like that, you should get your answer pretty quickly. So then dividing our 20 miles by our 30 miles per hour brings us to yet another 2/3 of an hour. So our final answer is 50 over 4/3, which is equal to 150 over 4, which is equal to 75 over 2, which is equal to 37.5 miles per hour. Any questions on that? So Isabella, does this question look good to you?
I'm pretty sure, yeah.
The general idea is as long as you understand this concept, that distance equals rate times time, as long as you understand this concept, or if you understand how to work with your units, this question shouldn't be very hard. The really big hint here is just as long as you keep track of everything in your units, you're good. As long as you remember, okay, I'm starting with 20 miles and I want to reach some sort of hours. In order to reach some sort of hours, I need to multiply by hours, divide by miles. And I know that I have a conversion here of 30 miles per hour. This is actually just the exact same as the conversion questions that we tackled in our algebra class. That's really just it. So this question should not be very hard, as long as you keep this idea in mind. Distance equals rate times time. You can multiply through, divide through by whatever you want to get to your answer. Okay, Allison, I know you missed this first question. This first question you can always just watch the replay, but overall this first question, not too bad, as long as you make sure you have the formulas correct. Okay, we'll go ahead and move on to problem 8 then. Any other questions before we move on? All right, let's go ahead and take a look at problem number 8. Problem 8, if a hashtag b equals a minus 1 over b, what is the least positive integer a for which a hashtag 3 is also a positive integer? Okay, let's take a look at what's going on here. So a hashtag b results in a minus 1 divided by b. So Allison, let me ask you a quick question, okay? So a minus 1, does that increase your number or decrease your number? Allison? Oh, you're typing in the chat. Yeah, it decreases, right? I mean, think about it this way. No matter what a is, as long as you subtract 1 from it, your number is always going to get smaller by 1, right? So a minus 1, that top part always decreases your number. Okay, what about b? What about dividing by b? Does that increase or decrease your number, Allison? Dividing by b, does that increase or decrease your number? Yeah, so this will once again decrease your number. But to be actually more exact, division actually always puts you closer to 0. What I mean by that is if you start with a negative number, division actually makes you bigger. Think about -4 divided by 2. -4 divided by 2 is -2, which is technically bigger than -4. But you're never going to have to worry about that. And the reason why you don't have to worry about that is because you're looking for a positive integer a, which means the top part needs to be positive. And your b numbers are all positive here. You're dividing by 3s in this case. Well, if you're dividing by 3s, that's not going to change your number from negative to positive. So your top part needs to be positive, your bottom part needs to be positive. You're working with positive numbers. Division will decrease your answer. So what we're working with here is 2 decreases of my number. So what that means is I want my number to be as small as possible while this whole thing results in a positive integer. But since I'm decreasing down to a positive integer, what that means is I can pick the smallest positive integer and then figure out what number will reach that point. So what I'm saying here is I'm saying that we want to end up with the smallest positive integer as our final answer. This whole thing, a hashtag 3, #3, this needs to result in our smallest positive integer. And the reason why we want this to be a smallest positive integer is because if this is as small as possible, then that means that this a is as small as possible, because these will only decrease our numbers. Okay, so Allison, now that we've said that, what is the smallest positive integer that this could be equal to? Yeah, the smallest possible positive integer is just 1. Now, why do we say that this whole thing needs to equal 1? Because we're saying that this whole thing needs to be a positive integer, right? We're looking for a least positive integer a, which kind of says that this over here also needs to be the smallest positive integer possible. Okay, sounds good. So now let's figure out this. So what if we say that this right here, let's call that C. So now we know that C #3. So in other words, A #3 equals C. But first we know that C #3 equals 1, which means that C minus 1 over 3 is equal to 1. So Allison, what does that mean C is equal to? What value should C be here? C equals 3 minus 1? Not quite. So what we know is that C minus 1 divided by 3 is equal to 1. And then at this point, what you can do is you can multiply both sides by 3, which will tell you C minus 1 equals 3. And this will then say C is actually equal to 3 plus 1. Because you would add 1 to both sides to get rid of that minus 1. So now, Allison, you should know that C is actually equal to 4. And another way that you could have tested this was just say, okay, I know that 3 divided by 3 is equal to 1. If I need C minus 1 to equal 3, then I must have C equals 4. See, not bad, right? Pretty simple, straightforward, tells us that C is equal to 4. Okay, sounds good. And let's keep going. So if we know that C must be equal to 4, then that tells us that A #3 must be equal to 4, right? Because this was supposed to be equal to C. So now let's plug this in. We know that A minus 1 over 3 is equal to 4. So with this idea in mind, Allison, what should A be equal to? Yeah, A is equal to 13. That's exactly it. So that gives us A is equal to 13. Are we done with our answer here? Are we done here, Allison? Do we have our answer? Are we good? There's not. We've actually taken care of all of them, right? We said the A #3 was equal to C, C #3 was equal to 1. So we're done here. But what I'm saying is, are we done finding our answer? And the answer is yes, because we're just looking for A. So that's our answer here. A is equal to 13. Allison, does that look good to you? Okay. Gracie, Isabella, any questions on how we approach this question? Any questions on any of the, any of the parts that we used here? Any questions like that?
Not really.
No, I just have like one question regarding this kind of thing in general.
Like, what about it?
If this was sort of saying a different thing, is the fastest way to approach it just to sort of separate this into different chunks, to realize that A #3 just equals a different variable?
Yeah.
Is that just the fastest way then?
Yeah, this is generally going to be like a step-by-step approach. The idea here is we take this whole thing. We know that this whole thing needs to equal the smallest possible number, right? Because if this is the smallest possible number, that means A is our smallest possible number. So that's the first step. Figuring out what this probably should be equal to. It should be equal to 1. And at that point, we say, okay, let's bring this back one step at a time. we know that if this #3 needs to equal 1, then I know that this result in here needs to be 4. If I know that this result needs to be 4, I know that this right here needs to be 13. If we keep on going, then we can find again that that needs to be 40 or something like that. But the idea is we take it one step at a time. There's not really well, there is a way to do this more than one step, but that's actually quite annoying and you have to write out a bunch of stuff. It ends up being like a minus 1 over 3 minus 1 over 3 is equal to 1. And this doesn't look fun, does it?
No, I get it. Thank you.
Yeah, so the idea is we just do it one step at a time instead. Now, if you're a little bit more familiar with it, the only reason why I introduced the C here was because this is the first time we're seeing this, right? If you're a little bit more familiar with this, you could just go ahead and say a #3 needs to equal 4 instead of using that C intermediate step. That's more of a helping step. You don't actually have to introduce it. You could just say, okay, this needs to equal 4. That's the idea here. You could say, you could write like, instead of writing C minus 1 over 3, right? You could say a #3 minus 1 over 3 is equal to 1. And then you could find that a #3 is equal to 4. But the idea here is that this quote unquote variable can really be however much you want it to be. But yeah, that's really just it here. Any other questions, I guess? Hopefully that answered your question. It's just like when you have anything like this, where you obviously have multiple different parts to it, it's sometimes just easier. It's easier on the algebra if you just take it one step at a time. Yeah, that's the way that I would put it. Does that sound good? Okay, any other questions on this problem? All right, problem number 9. Isabella, you should actually be able to do this question. You're just not thinking about it fully. Okay, so a frustum is created by slicing a cone parallel to its base. The two circular bases of the frustum have radii of 8 inches and 12 inches, and the height of the frustum is 4 inches as shown. What is the height of the original cone? Okay, I promise you, Isabella, if you think about this the right way, you can do this question. All right, Isabella, do you notice what's going on here? What is this a part of?
It's
hard to picture, right?
Is it a cone?
It's part of a full
literally
cone. It literally tells us that this is cut out of a cone, right? So let's go ahead and picture, let's go ahead and piece together what the full cone looks like, okay? Sound good so far?
Yeah.
So putting together the full cone brings us to something like this, right? With a height of this right in the middle. Does that look good to you?
Yes.
Now let me ask you, Isabella, what do you notice right here and here?
Is it similar triangles?
It is. Those two triangles are similar. So what is the ratio of this triangle to this triangle?
8 to 12.
Well, this one to this one would be 12 to 8, right?
Oh, I thought you meant the other way around then.
Okay, well, you can do it the other way around too. It doesn't really matter. So 8 over 12 is equal to what over what? We know that this length right here is 4. But what is this length? We don't know this length, do we?
Nope.
So what can we do with it?
X. Or if you're looking for the whole thing, it could be 4 plus x.
Yeah, x plus 4 and x, right? So 8 over 12 equals x plus x over x plus 4. Does that sound good so far?
Oh, do you just cross multiply to get x?
Does that look good to you?
Yeah.
So what is the height of the original cone?
Is it 12?
It's 12. So all we did here,
that's not that bad then.
this question is not that bad as long as you draw out the full thing. as soon as you draw out the full thing, you can recognize that, wait, this height right here and these two cylinders, it just gives me, well, like one cylinder inside of the other. That just gives us a full-on similar triangle. That's all that we see here. Okay. Gracie, any questions on that problem?
No.
And Allison, did you recognize that these were similar triangles as well, Allison? Okay, yeah. And yeah, so that's really just all that we're seeing here. These are similar triangles. Allison, you weren't here earlier when I asked, but did you manage to do any of the questions here in the sprint round? No? Okay, and then Josh, what about you? Josh, you there? Oh, nothing from Josh, I guess. Okay. Yeah, so this question, it's really just similar triangles. As soon as you draw it out, you should recognize that this is actually just similar triangles. Okay, moving on to the next problem then. No questions here, right? All right. Problems 10, 11, and 12. Problem number 10. The median of an arithmetic sequence of 8 integers is 44. If the first term is 30, what is the value of the 8th term? So what we're being told here is a couple things. First off, there's a total of 8 numbers. So what this means is that your 8th term is your final term in this sequence, right? Let's think about this in a little bit of a simpler example. Let's say, for example, you only have 5 numbers. If you have 5 numbers, then your median is going to be your 3rd number, right? And if we know, for example, that my arithmetic sequence is 1, 2, 3, 4, 5, then I know that my median is actually just halfway between my 1st and my 3rd numbers. Or in other words, the distance from my 1st to my 3rd, or my 1st number to my median, is the same as the distance from my median to my last. Well, is this true for all arithmetic sequences? Let's test it with a different one. How about 1, 3, 5, 7, 9? Again, the distance here to here is the same as the distance here to here. Well, what if we have an even number of numbers? What if we have 1, 3, 5, 7, 9, 11? Well, the distance from 1 to 6, which would be our median, right? Because we have 2 numbers in the middle, that means you take the average of the 2, is the same as the distance from our median to our 11. So this gives us a bit of an idea. If the difference between our first number to our median is always the same as the difference from our median to the end, specifically just because it's an arithmetic sequence of numbers, that means that the difference between each of its terms are always the same. We can prove this we can actually even prove this with our numbers, right? If we say that our first number is a, and then each number is a plus d, a plus 2d, a plus 3d, a plus 4d, right? Because each number is just the previous one plus d, plus d, plus d, a plus 5d, a plus 6d, and a plus 7d. We know that our median right here in the middle should be a plus 3.5d. The difference from here to the middle, the median, is 3.5d, and the difference from here to the end is another 3.5d. So what we find is that the difference between our first number and our middle term, our median, is the same as the difference between our median and our final term. So with all of this in mind, Gracie, what's our answer?
3.5.
Well, 3.5 times the difference, right? That's what like 3.5 times the difference is the difference from our first to our middle and our middle to our end, right? Our median to our end. But for this specific question, what is our answer? What is the value of our final term?
7.
Where'd you get 7 from? How'd you solve that?
Isn't it 3.5 plus 3.5?
Well, okay. That's when this was the general case where we're looking at 3.5d, right? 3.5d, that d represents the difference between our numbers. We don't know our difference between our numbers, but the idea is that the difference between our first and our third, our median, the difference between our first term and our median is the same as the difference between our median and our end. Does that make sense so far?
Yeah.
And we saw that difference is 3.5D. That difference is 3.5D. What we're being told here in this problem is that the median is 44. So this A plus 3.5D, that is 44. Our first term is 30. So what is our final term going to be? We don't care about D. We are not asked to find a difference. We are not asked to find the intermediate numbers. We're just asked to find this final number. So what did I say about this? I said that the difference between our first and our median is the same as the difference between our median and our end. So what is our ending number?
14.
Okay, do you know what an arithmetic sequence is?
It's a continuing pattern.
That's what sequence in general means, yes. Arithmetic sequence means each number is the same difference added from the previous one. Does that kind of make sense?
Yeah.
Okay, so let me ask you then. If I'm increasing, right? Because the median is obviously bigger than my first number. So that means my numbers are increasing, right?
Yep.
So if my numbers are increasing, does it make sense for my final number to be 14, which is smaller than 30? Does it make sense for that to happen?
No.
It doesn't make sense. Okay. So that's why 14 is wrong, because my numbers are increasing. My numbers are 30 at the start. In the middle, I have 44. And at the end, I should be even bigger. I should not be smaller than 30. I should not be smaller than 44. I should be bigger than both of these, right? So that's a quick check to know that 14, 7, 3.5, that's a quick check to know that all those answers are wrong. Does that make sense?
Yeah, then would it be 58?
Yes, because what we're saying is that, again, the difference between our first and our middle is the same as the difference between our middle and our end, right? That's what we proved. So that means our answer here is 58. Because this difference is 14, so once again, we add that difference here to 58. Isabella, is that what you wanted to say, 58?
No, I don't really get how you got 58.
So did you understand the part where I explained why the difference from your first to your median is the same as the difference from your median to the end?
No.
Okay, so let's start off with the arithmetic sequence again. So your first term is A. This is always the case for any arithmetic sequence. You always start off with A. But what the arithmetic sequence is you always add the same difference to your previous term. So does it make sense why my terms are A plus D, A plus 2D, A plus 3D? Does it make sense why these are my terms? Isabella,
Are
does
you
that make
just adding like an extra D?
We're just taking A and we're adding D, yeah. We're just adding D.
Yeah, that makes sense.
And then from A plus D to A plus 2D, we're just adding D again, and we're adding D again. Does that make sense? Does this all make sense here?
Yeah.
Okay, how many terms do I have here?
8.
Yeah, so this represents the 8 integers that we're looking at here. These are my 8 numbers. The median of this is going to be the same as if I cross off my numbers from my left and my right, one at a time. I'm left with 2 numbers in the middle. So my median is going to be the average of these 2 numbers. Does that make sense?
Yeah.
So if I average these 2 numbers, that means I just add them together, which means 2A plus 7D and divide by 2, which gives me A plus 3.5D. Does that sound good so far?
Yes.
So what's the difference between A and A plus 3.5D?
3.5D.
And what's the difference between this and A plus 7D?
3.5D.
So that means that these two are the same,
Oh,
right?
so they're the same.
The distance from my first number to my median is the same as the difference between my median and my end. Well, my first number to my median is 14. So my median to my end, 8th term, is again 14. So my final answer here is 58.
Oh, that makes sense. Thank you.
That's the idea here. No problem. So if you understood this process about the arithmetic sequence already, you wouldn't have to go through this whole step of proving it. But of course, if you guys haven't really worked with arithmetic sequences, then you wouldn't know that. But yeah, so if you already knew that that's the case, if you didn't have to go through that whole proving, whole idea of proving that that's the case, then you would be able to do this question really quickly by just saying, okay, 30 to 44 is 14, another 14 is 58. Okay, problem number 11. The hypotenuse of isosceles triangle ABC is a side of square ACDE as shown below. If AB is 4 units, then what is the length of segment BE? Express your answer in simplest radical form. So Allison. So for geometry, we learned this today, right? What triangle is ABC? What kind of triangle is ABC? Allison, what kind of triangle is it? Well, yeah, it's a right triangle, but did we learn anything else about it? Come on, Allison, that was like an hour ago. Yeah, it's a 45, 45, 90-degree triangle. And what we know is that AB over here is 4. So you should be able to tell me really quickly what AC and BC are, right? What are those two lengths going to be, Allison? Four and 4 square root of 2. That's right. So this over here, BC is another 4, and AC over here is another 4 root 2. Okay, sounds good. So what we're interested in is how to find the length of BE. Okay, Gracie, any thoughts on how we can find BE? What is the way that we could find it?
I don't know.
Were you here for the, are you in my geometry class? You are, right?
Yeah.
Were you here today?
Yes.
Okay. Is there any right triangle that we could draw using EB as our hypotenuse?
It would be BAE, but I don't think that's right.
BAE is not a right triangle, right?
Yeah.
That doesn't really help us out. Is there any one line that we could draw that would give us, is there any 2 points that we could connect that would give us a right triangle?
E and C?
Yeah, if we connect E and C, we'll notice that this right here gives us a right triangle with a hypotenuse of EB, right? So now all we need to do is we need to find BC, we need to find EC, and then we can find the value of this side right here. Does that make sense, Gracie?
Yeah.
Okay, so now we just need to find EC. Well, first off, let's prove that this right here is actually a right triangle. Does that sound good? We need to kind of prove it first, right? So we're told that ACDE is a square, right? This right here is a square, right?
Yep.
So what does that mean that this whole angle right here is? It's a 90-degree angle. Well, if we split it in two, like we did here with EC, what does that mean that that angle here now is? This angle right here.
45 degrees.
And what was this angle over here?
45.
So putting them together, that means that this is a 90-degree angle. Sound good?
Yeah.
So we've proven that we are indeed looking at a 90-degree triangle here. Okay, so now we just need to find the length of this. Well, we know a couple more lengths, right? We know that AC is 4 root 2, so that's one of the sides of my square. So that means that the rest of the sides of my square must all also be 4 root 2. Does that sound good?
Yeah.
Okay, so now that we're looking at a bunch of 4 root 2s, we need to find the value of EC. Okay, how can we do that? Gracie, any thoughts on how we can find the value of EC? Well, what is angle D? What measure is that?
That is 45.
Angle D is 45 degrees?
90.
Right, it's part of my square, right? So it must be another 90-degree angle. Well, what triangle do you notice this triangle right here is?
A 90-degree triangle.
Were you here for today's class?
Yeah, it was the x plus x equals x root 2
Not
triangle.
x plus x, but well, the three sides are x, x, and x root 2.
Yeah.
Do you know what's that called?
The 45 45 90 triangle.
And that's called 45, 45, 90 because of all my angles, right? So this right here is my 45, 45, 90 degree triangle, which means that this side right here is square root of 2 times bigger than this. So what does that mean this side is? How long is this?
32.
32? How'd you get 32?
No,
It's
32. No, it's not.
No. Well, however you're solving it, you're not solving it right. Okay. Remember, I think what you're doing is you're squaring things, and you're not supposed to be squaring things, okay? Okay, remember, for a 45, 45, 90 degree triangle, we have that these two sides are the same. We have that this right here, right? So this is x, this is x, this is x root 2. So what that means is I just multiply on another square root of 2. Does that make sense?
Yeah.
So if x is equal to 4 root 2, then what is x root 2 equal to? That's equal to 4 root 2 times root 2. Does that make sense?
That's kind of confusing.
Well, let me ask you this. What does the square root of 2 mean?
The square root of 2.
It means the number that when multiplied by itself is equal to 2, right? That's what square root means. The number that when multiplied by itself equals whatever number's inside this square root, right? Think about it that way. The square root of 64 is equal to 8, right? Because 8 times 8 is equal to 64. So what square root of 64 really means is what number, when multiplied by itself, equals 64. Well, 8 times itself equals 64. Does that make sense?
Yep.
So what is the square root of 2 times the square root of 2 going to be then?
2.
2. So when I say 4 root 2, what I really am saying is actually just 4 times the square root of 2. So if I'm saying that this times, if I'm looking for 4 root 2 times 2, the square root of 2, this is the same thing as 4 times the square root of 2 times the square root of 2. Well, you know what this is, right? What is that?
2.
So what is this? It's the same thing as 4 times 2, which is?
8.
That's not confusing at all anymore, right?
Yeah.
So how long is EC? EC is 8. So what does that make EB then? How do we find EB?
EB is 8 squared plus 4 squared.
And one way that I would like to simplify this is I'd like to say that this is 2 times 4 squared plus 4 squared, which is then equal to 4 squared times 2 squared plus 4 squared, which is equal to 4 times 4 squared plus 4 squared, which is equal to 5 times 4 squared, which is equal to EB squared. Square root both sides, we get that EB is equal to the square root of 5 times 4 squared, which is equal to 4 root 5 as our final answer. Does that look good to you, Gracie?
Yep.
If you want to actually work the full numbers, you can say that this is 64 plus 16, which is 80, and then you can say 80 is 16 times 5, which simplifies again to 4 root 5. Okay, any questions on how we did this problem? Isabella, does it make sense why I said, the 45, 45, 90 degree triangles will save you so much time? We used it actually twice in this question. We used one 45, 45, 90 here and one 45, 45, 90 here. Does that look good to you, Isabella?
Yeah.
Okay. And do you have any other questions on anything else that we talked about in this problem?
Nope.
Nope. All right. In that case, if no one else has any questions, then we'll go ahead and move on to problem number 12. Problem 12. A triangle with one vertex at 1, 0 is graphed in the first quadrant so that one side of the triangle is on the x-axis and another side is on the y-axis. If the area of the triangle is 3 units squared, what is the slope of the third side? So this question really just needs you to graph it out. As soon as you graph it out, you'll find that this question is not very hard at all. Okay, So if we're being told that one side is on the x-axis, that means that one side is along here. One side is along here. We're also told that it's graphed in the first quadrant. So if these two sides need to intersect, they will intersect at 0, 0. So we know that these two sides intersect at 0, 0, and one of my vertices is 1, 0. So I know that this side actually only goes to 1, 0. So one of my sides of my triangle is this. One of my sides of my triangle is somewhere around this. But we know that the area of this whole thing, this area is 3. Well, let me ask you one real question first. Isabella, how long is my base? If we count by
1.
units, it's 1, right? And if I know my area is 3, and I know that this right here is a 90-degree angle, right? This right here has to be a 90-degree angle. Would you agree?
Yep.
So if that is the 90-degree angle, then how high up must this go?
6.
So what point is this going to be?
6. Yeah, 0, 6.
0, 6. So what is my slope between these 2 points?
6 minus 0 over 0 minus 1. So like 6 over -1. So -6.
Do you see how easy this question was?
Yeah.
This question is not hard at all. Not hard at all, right? Gracie, Allison, any questions on this problem?
No.
Like some of these questions, you should not have any problems with them as long as you take a look, as long as you, draw things out a little bit. If you don't draw this out, this question can be quite challenging because you'll probably just get, you'll probably just not really understand what you're really looking for in this problem at all. But as soon as you draw this out at all, as soon as you just, draw out this whole thing, wait, this is 1, 0, this up here needs to go to 6. This question is not very hard at all. Okay, our answer here is indeed -6. All right, next 3 problems then. Let's go. Problems 13 through 15. Problem number 13 here uses an idea that we haven't learned yet in geometry, but I'm still going to go ahead and talk through it. But this idea we won't learn until chapter 7. I think specifically we don't learn it until section 7.5, but don't quote me on that. I think it's around there, but we should learn it around, no, 7.4. Yeah, 7.4. We'll learn this in 7.4. But it'll be a while before we get there. So the idea here is we have an equilateral triangle. Now, what we're looking for are a couple of things. First off, we are looking for the area of a circle that inscribes and circumscribes it. Now, you guys probably don't know what this means, but inscribed just means that it is the circle that fits perfectly inside of my equilateral triangle. And circumscribed means that it is the circle that perfectly fits outside of my equilateral triangle. Or you could even say that it is the circle that my equilateral triangle perfectly fits inside of. So what I'm looking for is the area in between these two. So I just need to find the difference between their areas. So in order to find this, I need to use a specific line. This is called the median. Now, what the median of a triangle does is it goes from one point of the triangle. So let's call this up here point A, B, and C. It goes from one point of the triangle, in this case point A, to the midpoint of BC. And then if we use the other 2 medians, we have one here from point C and one here from point B. What we find about these medians is that these 3 medians will always intersect at a single point. This point is called the centroid. Now, it just so happens that this centroid has nothing to do with the 2 circles at all. It has nothing to do with these 2 circles whatsoever. Because for the centroid, what we're actually interested in is the ratios of my sides, of the sides. So this length over here and this length over here. These ratios of a centroid is always going to be 2 to 1. That is always going to be the case for every single centroid. The long part is always twice as much as the shorter part. However, because we're working with an equilateral triangle, we have a couple other things. The center of my inscribed circle is what's called my in-center, which I can tell you without needing to draw anything is going to be right here, right on top of my centroid. And the center of my circumscribing circle, the one that goes outside, that is what's called the circumcenter. And that is also going to be right here. Now, why do I know this? Because I am working with an equilateral triangle. If I'm working with an equilateral triangle, all of these points end up being on the same spot. And this is something we're going to learn in chapter 7. Now, because of that, I know that my centroid is also the center of this small circle and this big circle. So I know that my radius here is half as much as my radius here. Well, I know that I'm working with an equilateral triangle with a side of 12. That means that this right here must be 6. That means that this right here, as we saw in the problems today, we haven't quite learned this yet, but this ends up being our second kind of special right triangle, which is a 30, 60, 90 degree triangle, which has side ratios of x, x root 3, and 2x, which means that this over here ends up being 6 root 3. We're going to learn this 30, 60, 90 degree triangle thing next week in our geometry class. But this right here ends up being 6 root 3, which means that, well, if this ratio is 2 to 1, then this part must be 4 root 3, and this part must be 2 root 3. So the areas of my two individual circles, one is going to be 48 pi, and one is going to be 12 pi. I subtract the 2 and I get 36 pi units squared. Now, I know that the answer here used a lot of information that we are not familiar with. I know it used a lot of details that we have not learned yet. But do I have any questions over anything other than the individual ideas here? So the proofs of all of those points, all of that stuff, all of that is going to be learned in chapter 7. This question just uses all of those ideas. But I think it's pretty easy to see that this length right here is a radius of this smaller circle. And I think it's also pretty easy to see that this length right here is the radius of the bigger circle. But the rest of everything that we learned here is stuff that we have not covered yet in geometry. So that just goes to show that when you're working in computational mathematics like this, geometry and algebra tend to be very, very important topics that you do want to have good knowledge of. Any questions on this problem that I guess that we could answer? Because if it's any questions about like, okay, why is this the center or whatnot, that's stuff that we're going to teach in the geometry class later on. That's something that is not a good idea. Is not something that we should really talk about here. But yeah, I guess this question was really a big preview of the stuff that we're going to see later on in the books. All right, moving on. Problem 14. Jane's drawer contains 6 white socks, 4 black socks, and 2 red socks. Jane reaches into the drawer without looking and randomly selects 2 socks. What is the probability that the 2 socks she selects are the same color? Express your answer as a common fraction. Okay. 1 second. Okay, so for this question here, Isabella, let's have you help me out with this one. So for this question, we're working with probability, right? So what does probability mean?
Probability sort of like, well, this is not like the best description, but sort of
No
like
worries.
the chance of something occurring or like something happening.
So it's a chance, right? It's a fraction. So what goes on top? Like what's the
Like,
numerator?
the numerator is sort of like the thing you're sort of looking for, kind of,
Yeah.
and then the
So the numerator is what you're interested in, the event that you care about, right? The event that you're
Yeah.
looking for. And what about the denominator then?
the denominator is sort of like total things happening or like total things.
Yeah, the total possibilities, all the different possibilities that could go on, right? All the possible different results. So what we're saying here is our numerator is going to be how many ways there are to pull out the two same color socks. And the denominator is going to be how many different ways are there to pull out two socks at all. Does that make sense, Isabella?
Yep.
So we're looking for two same over two socks. Okay, so how do we find the number of ways to get the two same color socks? How can we do that? Well, one way is what we call casework. Now, what casework is we consider each individual case, each individual situation differently. And at the very end, we add them all up together. Now, the reason why we do this is because sometimes the number of different outcomes, the number of different ways for something to happen changes depending on the certain situation. For example, in this case, you can clearly see that there's a wildly different number of ways to pick two white socks rather than two red socks. Does that make sense so far? So we're looking for, yeah, okay. So we're looking for the different cases of pulling out the same color sock. Well, it just goes to show that pretty easily, it should be pretty easy to tell that your three cases for the same color sock are going to be pulling out two white socks, pulling out two black socks, and pulling out two red socks. So this is the same thing as 2 white plus 2 black plus 2 red over 2 socks. So what we're looking for is how many ways are there to pull out 2 white socks? Well, what we can do here is we can just do a little bit of multiplication. Why so? Well, if you need to pull out 2 white socks, then how many choices do you have for your first sock that you can pull out? You have 6 because there's 6 white socks for you to pull from. As long as you pull any of those 6, that counts as a white sock. Okay? So then you just pull a second sock, and your second sock also needs to be white. Well, for your second sock, if it also needs to be white, then what are we looking for? Well, you already pulled out 1 white sock, so your second choice, you only have 5 choices remaining. So that means you have 30 ways to pick out 2 white socks. Now you might say, well, what if, let's say, one of them is white sock number 1 and one of them is white sock number 2? Isn't pulling out white sock 1 then white sock 2 the same thing as pulling out white sock 2 then white sock 1? And the argument here is, well, it is. But it's easier to think of things this way because as long as you do the same logic here, as long as you count both sock 1 and sock 2 as well as sock 2 then sock 1, it doesn't matter. That's the idea here. As long as we consistently do it the same way, it doesn't really matter. So we have 30 ways to pick out 2 white socks. We're also counting the order in which they're pulled out. So for example, we might say that the first sock is put on your left foot and the second sock is put on your right foot. So it does change. The order of them does matter. That's what we're saying here. Okay. What about two black socks then? Gracie, how many ways are there to pull out 2 black socks?
4.
Is that it? Only 4 ways? Well, let's look at the white socks, right? If the white socks was just 6, then maybe, yeah, 4 would make sense, but that wasn't it for the white socks, right? The white socks had a total of 30 ways.
Yeah, but how did it get 30?
Remember, what we said was you have 6 choices for your first sock, and on your second choice, because you're pulling twice, right? On your second choice, you can pull any of the 5 remaining socks. So we just do 6 times 5. So what about for the Black Sox then?
4 times 3, that's 12.
Yeah, that's 12. And what about for Red Sox? How many ways are there to pull out your Red Sox?
2.
2. Because you could pull out Red Sox 1, then Red Sox 2, or Red Sox 2, then Red Sox 1. There's 2 ways to do that. That's really what we're seeing here. Okay. Now, how many ways are there to pull out 2 socks in general? So first off, Allison, how many socks do we have in total? We have 6 plus 4 plus 2, which is 12. So we have 12 socks in total. So our first choice, we could pull any of the 12 socks. For our second choice, how many socks can we pull from? For our second choice, how many socks can we pull from? Well, this ends up being 11 because you just pulled out 1 sock from the 12. So now there's only 11 socks left for you to pull out the second one. So this ends up being 12 times 11. Well, our top is 30 plus 12 plus 2, which is 30 plus 14, which is 44 over 132, which is 4 times 11 over 12 times 11, which ends up being 4 over 12, which ends up being 1 over 3. So our answer here is 1 over 3. Any questions on this problem here? Isabella?
I got how you did this all the way up till like we got like the 2 socks problem. Are we just looking for like 14 plus 12 plus like 13? I mean, not 14, sorry. Like 12 plus 11 plus 10 plus 9 plus 8 plus 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1.
What are you doing there?
Like how did you get the 132?
12 times 11.
Yeah,
There's
but
12 socks for you to pull from first, then 11 socks for you to pull the second sock. How many total ways are there for you to pull out 2 socks? Well, 12 choices for your first sock, 11 choices for your second. That's why.
Oh, yeah, that makes sense. Thank you.
Yeah. It's a lot easier than whatever you're doing. But yeah. Anything else then?
Nope, thank you.
All right. If not, then that's all the time that we have here for today. Homework is, well, please give the rest of the questions a shot. I know they are very hard, but there should be at least a couple that you can maybe take care of. I think problem number 16 is one that you guys should take a look at. That one I think you guys definitely can do. The other ones, good luck, have fun. But with all that being said, next time we'll keep on going through this. We'll start up from problem number 15. And with that, I'll see you guys next week. Have a good rest of your weekend. See you guys next week.
Bye. Have a good
Bye.
rest of your weekend.
Yeah,
Thank
yes,
you.
yeah, thanks.